Hello friends, welcome to my YouTube channel Enqueue Coding. In today's session we discuss the data structure queue and how to perform queue operations that are Enqueue and Dequeue. In this session we also discuss the algorithms to perform Enqueue and Dequeue operation. So let's start. I hope all of you familiar with the queue data structure. So first we discuss some important points about the queue data structure. Queue is a linear data structure. Linear means if you know the starting address of the element, then you can visit all elements of the queue. In this data structure, insertion and deletion occur at different ends. So here for insertion we use rear variable, and for deletion we use front variable. Rear use for insertion and front use for deletion, because in this data structure insertion and deletion occur at different ends. So insertion occurred at a rear end and deletion occurred at a front end. So the most important point here is rear variable used for insertion and front variable used for deletion. That is the second point. So now the third point is, at the starting time queue is empty. At that time both rear and front are initialized with value -1, because -1 index is not existed. When the queue is empty, it means there is no element in a queue. At that time rear has a value -1 and front also has a value -1. Now all of you know queue is implemented by two ways. One is using arrays, second one is using linked list. Because we have two type of memory allocation. One is static memory allocation, another one is dynamic memory allocation. So if you want to implement queue using static memory allocation, at that time we implement queue using arrays. If you want to implement queue using dynamic memory allocation, then we use linked list. Do you use linked list? If you want to implement queue using dynamic memory allocation, we use linked list at that time. So basically queue have two operations. One is Enqueue, another one is Dequeue. Enqueue means insertion, inserting an element, and Dequeue means deleting an element from queue. Deleting an element from queue. Okay. And queue work upon the principle of FIFO. FIFO means first in first out. First in first out means the element which inserted first also deleted first. That is first in first out. So now in this session here I implement a queue using arrays. So queue is the name of an array of int type, and size of the queue is 5. It means how many locations in this array? It means in this array we have 5 locations. 0 to 4 index, 5 locations. First, second, third, fourth and fifth location. Here our array is ended. 0 to 4, how many locations? 5 locations. So at the starting time, if you analyze here, queue is empty. There is no element in a queue. So that's why rear and front both has a value -1. Both has a value -1. Rear has a value -1. Front also has a value -1. Now we discuss how we insert the element in a queue, and after that we discuss how to delete, how to perform the dequeue operation on a queue. So now first we perform Enqueue operation. So what we are performing? We are inserting an element 10. So at the very first time queue is empty. When we insert first element, this 10 is our first element. When we insert first element in a queue, at that time both rear and front are updated. We are implementing linear queue. In linear queue, here we are implementing linear queue. Now in linear queue, the formula for updating rear and front is rear is equal to rear plus 1, front is equal to front plus 1. So at the starting time, rear has a value -1, front has a value -1. Now we apply this formula. When we insert this element Enqueue 10. So first, now what are the steps for performing Enqueue operation? The steps are: first step is update rear, second step is update front, third step is insert item at queue of rear. So here rear has a value -1, -1 plus 1, it become 0. This 0 return to the rear variable. It means now rear point to which location? 0 index. In a similar way, front also has a value -1, -1 plus 1, it again becomes 0. So now front update value 0. So front also point to the same location. So when we insert first element, both rear and front point to the same index, that is 0. Because when we insert first element, both rear and front are updated. And when we insert second element, third element, fourth element, except first element, then only rear is updated. I show you in the coming steps. So here rear has a value 0. So Q of 0 is equal to 10 because our item is 10. So 10 is inserted here. After this, now we insert second item. Now we perform Enqueue 20. So first step is rear is updated. Second step is inserting an item. So now 20 is our second item because 10 is already inserted here. So in this case, only rear is updated. What is the last value of the rear? Last value of the rear is 0. So 0 plus 1. 0 plus 1 is 1. 1 return in the rear variable. And Q of 1 is equal to item. Item is 20. So at 1 index, 20 is inserted. I hope all of you understood better. I hope सबको समझ आ रहा होगा. Okay. Now, if you find any difficulty in queue operations, you can message me in comments. Okay. Next is now we perform third operation, that is again we perform Enqueue 30. Now how to perform this operation? Now 30 is our third element. So first step is rear is updated. What is the last value of the rear? Last value of rear is 1. So 1 plus 1, it become 2. And Q of 2 is equal to item. What is item? Item is 30. So it means at second index 30 is updated. At second index 30 is inserted. Now if you analyze whole array, rear have value 2, but front is not updated. Front has a value 0 because when we insert first element at that time only front is updated. So front has a value 0 at this time and rear has a value 2. Now now again we perform another Enqueue operation. So now we perform Enqueue 40. Now we perform now we insert another element, that is our fourth element. Okay, so what are the steps? Steps are same. So first step is rear is updated. What is the last value of rear? Last value of rear is 2. 2 plus 1, it become 3. And Q of 3 is equal to item. What is our item? Item is 40. So at 3 index, now rear is pointing to 3 index. Okay, and 40 is updated. Front is same because except first element, whenever we insert any element, then only rear is updated. Now we perform another Enqueue operation. Now we performing Enqueue 50. So here, what is the last value of the rear? Last value of rear is 3. So 3 plus 1 is 4. Rear has a value 4. Q of 4 is equal to 50. So at fourth index, 50 is updated. Now rear point to the fourth index. Rear point to the fourth index front. So at this time, now Q is full. At this time, rear has a value 4, front has a value 0. Okay, so this is also the condition. This is also the condition when the queue is full. If anyone asks you when queue, what is the condition for checking the queue is full, you can say if rear double equal to n minus 1, at that time, and, or you can say here and front is double equal to 0. If this condition values to true, then we can say that Q is, you can print Q is full. This is just a message. You can print Q is full at that time. So this is the condition for checking Q is overflow or not. If this condition is satisfied, if rear has a value n minus 1, because n has the value 5 here, 5 minus 1, 4. If rear is equal to 4 and front is equal to 0, you can check here. Front has a value 0, rear has a value 4. So I hope everyone clear when the queue is overflow and how to perform the enqueue operation. I hope सबको समझ में आ रहा होगा. Okay. Now we perform another operation. Okay, now we perform dequeue operation. Now, because Q work upon the principle of FIFO, so which element is inserted first? 10 is inserted first. So we delete this element first, because Q work upon the principle of FIFO, first in first out. The element which insert first also deleted first. So first we delete this 10 element. So first we delete this element, that first element. Okay, now how to perform? What are the steps? Steps are, so for performing dequeue operation, what I do, first I fetch this value in some variable. So I write here item is my some variable. Item is equal to Q of front. What is the value of front? Front has a value. What is the value of front? Front has a value 0. So Q of 0. What is the value of Q of 0? Q of 0 is 10. 10 go where? 10 go in this item. 10 go in this item. And front is equal to front plus 1. What is the value of front? Front has a value 0. 0 plus 1, 1. So front point to which location? Front point to this 1 index. I hope all of you clear how to perform the dequeue operation. So now we perform another dequeue operations. Okay. Now I perform dequeue 20. Okay. So again, what are the steps? Steps is, first we fetch the value. So item is equal to Q of front. Okay. So in the last step, front has a value 1. Now Q of 1 is 20. Q of 1 is 20. So 20 go in this item. Then front is equal to front plus 1. What is the last value of front? Front is 1. 1 plus 1. 1 plus 1 is 2. It means now Q point to this second index and this 20 is deleted from here. Okay. Now we perform another dequeue operation. So now we perform dequeue 30. Now steps are same. Okay. When we perform dequeue operation, first step is, first we fetch the value. Second step is front is updated. So item is equal to Q of front. What is the last value of the front? Last value of the front is 2. Okay. It means Q of 2. Q of 2 go where? Q of 2 go in this item variable. What is the value of Q of 2? Q of 2 is 30. So 30 go here. And after this, front is equal to front plus 1. 2 plus 1, 3. Front is updated to the, after deleting this 30, front point to third index. This one. I hope all of you clear. I hope all of you clear how to perform the dequeue operation. So now our queue is empty by 3 locations, because first 3 elements are deleted. Okay. Now if we perform Enqueue 60, if I perform another Enqueue operation, then we check the condition. If rear double equal to n minus 1, okay. Now rear has a value 4 is equal to 5 minus 1 4 condition true. It means now Q is full. Okay. The thing is, for checking that Q is full, this is only the condition. Sorry, this is only the condition. Rear is equal to n minus 1. Okay, rear is equal to n minus 1. If rear is equal to n minus 1, it means Q is full. This is for checking Q is full or not. Okay. So if rear is equal to 4, because rear point this location, it means Q is full. Now we are not able to insert next element. So the thing is, we are not able to insert the element 16Q because there are no, because the rear has a value n minus 1. Although there are some empty locations, but we are not able to insert next element in a queue. So this is the disadvantage of the linear queue. So to avoid this issue, we use linear queue. So thanks for watching my video, and if you like my video, kindly comment, share and subscribe my channel. Thank you all.